All right, so this is the second video going over the pizzazz for 817, where it says, where do generals keep their armies on the top? Make sure you turn in the work paper for this next on the module. All right, and remember that you have to have all the turn in the work part turned in for all 4 days to take the quiz on Friday. All right, and let me know if you need help before you get there. I'm wanting to prepare you to do well on that. All right, so let's look at number 4 next. Karen's hobby is chemistry. For one experiment, she used 3 liters of water in 3 empty beakers. She poured 0.7 liters into the first beaker and twice that amount into the second. How much water was left for the third beaker? So we have 3 beakers here. We have 1, 2, 3, right? We have 3 liters of water. So in the first beaker, all right, we have, she has 0.7 liters. Twice that much in the second one. So 0.7 times 2 is going to give us 1 decimal place in the problem. So 1 in the answer, 1.4 liters. So together, she's already used 2.1 liters. Okay, that's an L for liters. So if she had 3 liters of water, how much is left for the third one? Well, we're going to take 3 liters. We can make that 3.0. Subtract the part she's already used, and that'll give us 9 or 0.9, 9/10 of a liter. All right, so 0.9 liters is N. So for number 4, we have an N. All right, number 5, we have Mia makes decorative candies by pouring melted chocolate into molds. Each mold, like not mold, but like, the thing that holds something, holds 0.4 ounces of chocolate. Mia bought a 20-ounce bag of chocolate, but has already used 10.4 ounces. How many candies can she make with the chocolate she has left? Well, first we need to see how much chocolate she has left. So she had 20 and she's used 10.4. So to see how much is left means subtract. All right, so we got to line up the decimal. There's no decimal in the 20, so that means it's at the end. And we need a 0 here to line up and subtract. All right, so that gives us 10 minus 4 is 6. 9 minus 0 is 9. So 9.6 ounces she has left, and each mold holds 0.4 ounces. Okay, so it's kind of tough to figure out, but this means we're dividing it up into different parts because we're, seeing how many of them we can divide it up into. So we have 0.4 on the outside of our division. And top dog's in the doghouse, so 9.6 inside. Move to the end on the outside, do the same on the inside. So it's going to come up right here. Therefore, our problem here is actually going to be just 4 into 96, which is going to give us a whole number. So 4 goes into 9 2 times. Then 4 goes into 16 4 times. 4 times 4 is 16. All right, no remainder. So on number 5, she can make 24 candies, right, which is V. All right, so that goes right there. All right, number 6, Luis brought 2 pieces of wax to make candles. One piece weighed 3.49 kilograms. The other was 4.71 kilograms. If wax is $1.80 per kilogram, how much did he spend all together? Well, let's first figure out how much his 2 pieces together weigh, which means we're going to have to add them up. So we're going to go 3.49 plus 4.71. All right. And so that's $8 or 8.28 and 20 kilograms. So I'm going to shorten that to 8.2 because that's going to make our multiplication easier. So wax is 180 per kilogram. So what I'm going to do here is I'm just going to do 1.8. Well, I know 0 on the end. It doesn't actually mean anything in terms of place value in that case, right? So we go 8 times 2 is 16. 8 times 8 is 64, and 1 is 65. All right, then we have 2 and we have 8. Okay. So 2 decimal places in the problem, so 2 in the answer. So he's going to spend $14.76 all together, which is I. So for number 6, we got several I's right here. I. Okay. 7, Keogh's model airplane uses 0.03 or 300ths liter of fuel each minute it flies. If the fuel tank holds 0.5 liters, how long can the plane fly without refueling? We're going to round to the nearest tenth of a minute. Okay, so we have here, basically, we have that he has 0.5 liters of fuel, right? And it's using 0.03 liters per minute. So we're going to divide like this. So we have 0.03 top dog in the doghouse right here. Move it to the end on the outside. That was 2 places. So we move 2 on the inside. Same on the outside and inside. Add a 0, bring the decimal up. So basically, we're going to end up doing just 3 into 50 here. And it said round to the nearest 10. So 3 into 5 one time. 3 times 6 is 18. Remainder of 2. Decimal. Bring it up. All right. Then we have 3 times 6 is 18. Now it says round to the nearest tenth. That means we need to go to 2 decimal places or hundredths to round to 1. All right. So that's going to be 6 again. This would go on and repeat, but it says to round to 1 decimal place. So that 6 is going to tell that one to go up. So we're going to get 16.7. So our answer is going to be, he can fly 16.7 minutes. All right, which is going to be H. So right there. And then last one, number 8, scale model of a train has an engine that is 17.2 centimeters long and 10 cars that are each 13.5 centimeters long. Okay, so I think you should at least be able, if you're stuck on this, please make sure you at least have figured out how long the model train is. You should be able to figure that out, okay? Show some perseverance. All right, so get that done and then kind of come back to it. All right, so each of the cars are 13.5 centimeters long. So there's 10 of them. So when you multiply by 10, you basically just move the decimal to the right one time. All right, so that's going to be 135. So the cars make 135 centimeters, plus the engine is 17.2. Okay, so then that gives us, bring the decimal straight down, 152.2 is going to be the length of the train. All right, so now what we got to do here is that each centimeter on the model represents 0.8 meters on the actual train. So we're actually going to take our length of our model here, and we're going to multiply it times 0.8. All right, so 2 times 8 is 16. 17 there, 40, 41 there. 8 times 1 is 8, 4 is 12. 2 decimal places in the problem, so 1, 2 in the answer. So we have 121.76, which is going to be right here. All right, so 121.76 meters. And we'll work more on the ratio concept that got me to that point on that problem. So I'm just showing you what we're doing on this one. All right. Okay, so that finishes our sheet up here. Make sure you got the work to turn in. And the answer to the riddle, where do the generals keep their armies? They keep them in their sleeves. Think about your arms, right? In their sleeves. So instead of that, it's their armies in their sleeves. So that's the end of this. Hopefully you'll be, make sure you're ready for the quiz tomorrow.